Math 1000, this is the practice test for chapter 6. For question number 1, you are to state the domain. The domain is all of the x values that you can plug into this problem. This is a rational expression, it's a function. And if you were to make a table of values, if you were to graph this, what numbers for x is your domain, what numbers would you be able to plug in to graph this? Well, what you would not want is you would not want a 0 in the denominator. So if you were to have a 3 right here, because 3 minus 3 is 0. If x were 3, this would have a 0, this fraction would have a 0 in the bottom. So to find the domain is going to be, when you have a rational expression, the domain is going to be all real numbers except when the denominator is set equal to 0. So you're going to set x minus 3 equal to 0. Set this equal to 0. You're going to solve for x. X equals 3. So your domain is all real numbers in set notation such that x cannot be 3. So your answer is B. For number 2, again, you're going to want to look at your denominator. You're going to want to factor x squared minus 16. So you set your denominator, x squared minus 16 equal to 0. This is the difference of two perfect squares. And so the two numbers that would give you, that would make this or this equal to 0 would be x equals 4 or x equals negative 4. So your domain would be all real numbers in set notation, all real numbers such that x cannot be plus or minus 4. So the correct answer would be A, just like that. Now for number 3, if you look at x squared plus 4, when you set this equal to 0, this is not the difference of two perfect squares. This is not factorable. So it does not matter what number you square. You will never get this. You'll never get a 0 here, because when you square any number and add 4 to it, you'll never get a 0. So your domain for this one is all real numbers. You're never going to get a 0 in that fraction. Okay, number 4. Simplify the rational expression, and you are to state any restrictions on the variable. Now, the restrictions are when you have a 0 in the denominator, and you're going to state the restrictions before you do any canceling. So your job is to factor the numerator and the denominator completely. So for the numerator, how do you factor p squared minus 4p minus 32? Well, that is p plus 4 times p minus 8. All over p plus 4. So our restrictions are p cannot be negative 4. P cannot be negative 4. So it's got to be one of these two. It can't be these. So we already know it's not B or D. It's one of these two. Now when we cancel, we're going to cancel those two. So the only thing left is p minus 8. So the correct answer is C. So the simplified answer is p minus 8, and the restriction is p cannot be negative 4. Make sure you state your restriction before you do any canceling. Number 5. We need to factor. We need to factor this piece and this piece. So we have z squared over z plus 1 times, this factors to be z plus 2 times z plus 1 over, we're going to factor a z, and you're going to have z plus 3. So we are going to state all of our restrictions first. So for every variable in the denominator, you're going to have a restriction. So you're going to have a restriction right here. If you set z plus 1 equal to 0, we know that z cannot equal negative 1. That's a restriction. Z cannot be 0. And z cannot be negative 3. So we have 3 restrictions. So I already know that this can't be an answer, and this can't be an answer. So it's got to be between this one and this one. So I can cross these 2 answers out. So now let's do our canceling. What cancels? Well, I know the z plus 1's cancel. That's a match. And one of the z's here cancels with one of the z's here. And that looks about it. So the only thing left is z going across. So we have a z left and a z plus 2 all over z plus 3. Which, if you were to distribute, you end up with this answer with these 3 restrictions. So D is the correct answer. Number 6. Number 6, you are going to divide. When you divide, you flip and multiply. So we have x plus 2 over x minus 1. We're going to flip this, and we have to factor. We're going to factor this, and I'm going to save some time. I'm going to factor this and put this in the numerator. Okay, now, so I'm flipping and I'm going to multiply, and what cancels? Those cancel, and it looks like that's it. So what's left? We're going to go across x plus 2 times x plus 5 over x plus 4, and the correct answer is D. Next one. Simplify the difference. We are subtracting here. Now we cannot add these 2 up or subtract because they have different denominators. So I want to see what this denominator is, so I want to factor this. And I bet you one of the factors is going to be x plus 3 of this. So we have, and you don't have to factor this piece, but this bottom is going to be x plus 3 times x minus 1. And I'm going to turn this, I always make my subtractions a plus, but I'm going to attach that negative to the 5 here. So I'm going to give this negative, the negative to this 5 right here. Okay, all I did was factor this, because I need to see what the common denominator is. Now, looking at this problem, my common denominator is x plus 3 times x minus 1. So what I need to do is I need to multiply this fraction by x minus 1 and x minus 1. Whatever you do to the bottom, you have to do to the top. So, next, what I'm going to do, I'm going to distribute this. So I have x squared minus 4x minus 12. And I'm going to distribute negative 5x and then plus 5. All over, put it all over this denominator. Now clean this up. What is common? Well, these two are like terms. So I have x squared. Negative 4x minus 5x is negative 9x. Negative 12 plus 5 is negative 7. All over x plus 3 times x minus 1. Now, I can't factor that. That's not factorable. So looking at my answers, it looks like this is surfacing, this numerator is surfacing right here. I don't see it here, here, or here. And my bottom, looks like what they did was they just factored this back. So all that this is factored back into that polynomial. So the correct answer is A. Number 8. When you have two fractions set equal to each other, we have just two fractions set equal to each other, what you can do, the easiest thing to do is to cross multiply. So we can multiply these two together, so g plus 4 times g minus 8. So g plus 4 times g minus 8 equals g minus 2 times g minus 5. A little bit of review of foiling. So if we multiply these two together, you have g squared. We have minus 8g plus 4g minus 32, which simplifies to g squared minus 4g minus 32. On the right side, we have g squared minus 5g minus 2g plus 10. Be careful with your adding and subtracting. Okay? Next, we have 1 for 1 here. These two g squareds, they will cancel each other out, which is nice. So all you're going to do now is solve. You're going to solve this problem for g. I would bring this negative 7g over here. I'm going to add 7g. So you get 3g then I'm going to add 32. And then divide by 3. And there is your answer, 42 over 3, which reduces to 14. Divided by 3 is 14, and your answer is D. Now, what's nice about this problem is you could actually plug this number in here, here, everywhere you see a G, you're going to plug 14 in. Now, be careful for extraneous solutions. Whenever you're dealing with an equation, you do not want any answers that will result in a 0 in the denominator. So an extraneous solution would be, if I came up with G is 2 or G is 8, those would not be good answers. We'd have to throw them out. So G could not be 2, G could not be 8, those would be extraneous. We didn't come up with those two answers, we're safe. Number 9. We are solving, we have to get rid of these bottoms. So if you factor a squared minus 36, you get a minus 6, a plus 6. Okay? Well, our greatest common denominator, or greatest common factor, is going to be a plus 6, a minus 6. So what you're going to do is you're going to multiply all three of these terms by a minus 6, a plus 6. Why? Because you want to get rid of those three denominators. You don't want them in the problem at all. So we're going to multiply each by a minus 6, a plus 6. So if you on the side put a minus 6, a plus 6 here, a minus 6, a plus 6 here, and don't forget, here, these are going to cancel. You're left with just an a right here. See, these are gone, so you have just an a. Be careful, bring down the sign. These, the a minus 6's cancel, so you have 2 times a plus 6 equals. And then the a plus 6's cancel, so you have 1 times a minus 6. Now all you're going to do is solve for a. So a plus 2a plus 12 equals 1a minus 6. Simplify this, which is you get 3a plus 12 equals a minus 6. Subtract an a, subtract 12, and divide by 2. And I got a is negative 9. Now what you could do is you could check your answer, but you want to make sure, again, you don't want 6 or negative 6 for any answers, which we didn't get. So automatically, I know I should have crossed that answer and that answer out, because those would be extraneous. A can't be 6 or negative 6. Number 10. Your least common denominator, if these were fractions and you were wanting to add them or subtract them, your common denominator, if you were looking at the 6 and the 7, your least common multiple of 6 and 7 is 42. So you'd have to do multiples of 6 and 7. So you need a 42 for sure for the number 6 and 7. Okay, so that's good. Now look at your x's. You need the greatest number of times you have an x, which is x to the 5th. Okay, so that's done. And now what's the most number of times you see y? And that would be y to the 3rd. That's how you get your GCF. And that would be letter C. Number 11. These ones I would like to see your work. You are going to factor completely. So for the numerator, what can you pull out? You're going to pull out your GCF for this one, which is 6a. Pull out a 6a. You're left with a minus 3b. Now, you can only cancel products. So 6 goes into 12 2 times, and these a's cancel. So your answer is a minus 3b over 2. Done. Next one. So let's do the numbers first. 7, we're multiplying. 7 goes into 21 3 times. And 3 goes into 15 5 times. So in my denominator, I have a 5. And we're done with that. Now let's do the x's. We have x to the 3rd here, and we have x to the 6th. So 3 x's on top, 6 on the bottom gives us 3 x's left on the bottom. And then for the y's, we have 2 y's on top, but 5 on the bottom. That gives us a difference of 3 y's on the bottom. There's a 1 left on top. Nothing is left on top except a 1. Everything's done. Next one. We have a complex fraction. We have a fraction, a rational number divided by another rational number. This is your main fraction line. So what you're gonna do is 4x squared over 3y squared. And you are going to divide, this is your main fraction line, so we are going to flip and make this 9y to the 4th over 8x to the 4th. So let's do our numbers first. 3 goes into 9. How many times? 3. 4 goes into 8. 2 times. So as far as the numbers go, we have a 3 and a 2. Let's get rid of those. We're done. Then we have our x's. We have x squared here and x to the 4th here. So these are gone. We're going to have x squared left. And then we have y squared here, y to the 4th. What's left? 2y's and a half. Another complex fraction. We have a fraction divided by a fraction. So we're going to factor this, which is x minus 8. We have 2 of them over negative 12x. Now I'm going to flip this. I'm going to put negative 2x on top and x minus 8 on the bottom. So I'm flipping this. This is going to go up on top and this is on the bottom. So what cancels? We're going to cancel one of those. The negative 2 goes into negative. This is going to be 6. The x's cancel. The negative 2, you have a 6 left. And so your answer is x minus 8 over 6. Number 15. We are multiplying. This is the difference of 2 perfect squares. We get 3x minus y times 3x plus y. This bottom is the difference of 2 perfect squares, just x minus 2. And then we have 3x minus y. So what cancels? One of each of those, one of each of these. And what's left is 3x plus y over x plus 2. That's your answer. Next one, you are adding or subtracting in this one. This one's subtracting. So, and the denominators are the same. So I am going to combine these two, which is going to be 5 minus x over x squared minus 25. Now, this is the difference. You always want to see if you can factor completely, or if it's factored completely. This is not factored completely because you want to simplify this. So you have 5 minus x on top, and this is the difference of 2 perfect squares. So this can be factored to be x plus 5, x minus 5. And we talked about in class that when you have 2 numbers that are the same but opposite signs, like this, see how this is 5, this is negative 5, this is negative x, this is positive x, you can cancel them, but you want to insert a negative 1. So, if you do not cancel that, you're going to lose some points. So you have to put your negative 1 in, and then it's x plus 5 at the bottom. Negative 1 over x plus 5. Now number 17, you can't add or subtract these because they don't have the same denominator. So what I first did was I turned this into a plus sign and I gave that negative to the 5 here. So my common denominator, I'm going to put parentheses around those 2 denominators, and I'm going to say, okay, what's my common denominator for these 2? Well, it's going to be, let me get a new sheet of paper out. My common denominator is going to be x plus 1 times x minus 1. So what do I want to do now? Both of these are my common denominator. So I need to go back now. I need to multiply 8. What's missing here? I have the x plus 1. I need, a lot of people say cross multiply. You need to pick this x minus 1 up. So you need to multiply this. It's not really cross multiplying, but you're going to multiply 8 times x minus 1. And this negative 5 needs the x plus 1. So now, what we're going to do is distribute. We have 8x minus 8 over x plus 1, x minus 1. And then this is negative 5x minus 5. Now we're going to combine. Now we have common denominators. So we can add the numerators, which 8x plus negative 5x is 3x. Negative 8 minus 5 is negative 13. All over, you're going to put it all over this denominator. And check to see if you can factor. If this was factorable, sometimes it is. Maybe you could factor something out and maybe cancel, but this you can't. There's no common factors between 3 and 13. This is prime. So it's done. This is your final answer for that one. There's nothing you can do. Okay, in the back side, number 18. This one you're going to want to factor this, and usually this is an indication that x plus 4 is going to be one of the factors, which it is. So you have 5 over x plus 4 plus 5 over this factor. This is the difference of two perfect squares. So we can't add these up because they have two different denominators, but this one's not that bad. So what you want to do is multiply the common denominator is x plus 4, x minus 4. So all you have to do for this one is multiply this first fraction by x minus 4 over x minus 4. Simple as that. So you get for this 5x minus 20 Okay, next, we're going to cross here. Actually, yeah. We're going to now add up our numerators. These two are like terms, so you have 5x minus 15. Now I see a 5 I can take out. I'm going to go ahead and try it out. Not that it's going to help. I took a 5 out, and even though I took the 5 out, there's nothing I can cancel. It's that answer, I could leave it. This answer was fine, or this answer was fine. These are both good answers. I would accept either one. Okay. If you don't see anything that you can pull out, but sometimes you have to do it to see. Would have been nice if this was x minus 4, and then I could have canceled those to make it simpler. Okay. Number 19, we have a complex fraction. What you have to do here is you've got to get these two fractions together. We have 3 over 1 here. We have to get these two in the same denominator. Same with this, and then flip and multiply. So what you're going to want to do is get a common denominator here. So what would you multiply both this top and bottom by? Would be x. So if you multiply this by x and this by x, you have 3x over x plus 2 over x, which gives us 3x plus 2 over x. That's that fraction. Now let's look at this one. This one, you're going to multiply this by x and this by x, so you have 2x over x plus 1 over x, which is 2x plus 1 over x. Now we have reduced this to two fractions. So one fraction divided by one fraction, this is your main fraction line. So what you're going to do is flip this and multiply it by that. So we have 3x plus 2 divided by x. We are going to flip this, and all that's going to happen now is we're going to see these two are going to cancel. So your final answer is 3x plus 2 over 2x plus 1. Please do not cancel these x's. This 3x plus 2 is stuck together, and the 2x plus 1 is stuck together. So that's your final answer. The last three are, you're going to solve these equations, and you always want to check for extraneous solutions. You'll have extraneous, you could have an extraneous solution if there are variables in the denominator. This one doesn't have extraneous solutions because there's no variables here. So what you want to do is look at this one. This one all consists of just numbers here. So what is your smallest common denominator here? So look at 6, 2, and 3. The smallest number that 2, 3, and 6 have in common is a 6. So you're going to multiply all of these 3 by 6. A 6 will wipe all 3 of these out. So watch. These 6's cancel. So you have 2x plus 1. Then plus, the 2 goes into 6 3 times. So you have 3x here. Equals, be careful here, and then 3 goes into 6 2 times. So you have 2 times x minus 1. No more fractions. So now we're going to simplify. We have 2x, or we're going to solve for x. Distribute. Add these two up. 5x plus 1. Subtract, swing this 2x to the other side. Subtract 2x, you get 3x. Subtract 1 and divide by 3. So it looks like x is negative 1. Now, can you check this? Absolutely. Anytime you have an equation, plug that number in, and you better get the same thing on both sides. But x is negative 1. That is your correct answer. Number 21. Whenever you have two fractions set equal to each other, don't forget cross multiplying. So 2 times x plus 2 is equal to 7 times x minus 3. So you get 2x plus 4 equals 7x minus 21. I would subtract 2x from 7x and you get 5x. I would add 21 to 4 to get 25 and divide by 5. X is 5. Now again, you're not going to have extraneous solutions because you have a 7 and a 2. There are no variables. X is 5. And the last one. You're going to want to factor this denominator here. These two are already factored. My guess is this denominator is going to factor to be x plus 10 times x minus 2. Let's check it out. Let's make sure. Is 10 times negative 2 negative 20, and does that add to be 8? It sure does. So, what we are going to do is figure out what our least common denominator is, which is x plus 10 times x minus 2. So what we have to do is multiply all 3 of these fractions by x plus 10, x minus 2. x plus 10, x minus 2. Don't forget all three. So what's going to happen? These are going to cancel. So you have 5 times x minus 2. Plus, both of these are gone. And the x minus 2 cancels, so you have 4 times x plus 10. We're going to distribute. You have 5x minus 10 plus 2 equals 4x plus 40. A lot of people forget to distribute that. Now we're going to simplify. 5x minus 8 subtract 4x and add 8. Add 8 to 40, you get 48. Now, could 48 be a solution? Yes. The only two solutions you don't want are negative 10, because that would result in a 0 here, or 2. We're good, we got a 48. Now, if you want to be 100% sure that that's the answer, you could take a second and plug 48 here, 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 anywhere you see an X, and do your math. But when you check your answer, you want to make sure you're plugging your fraction correctly into your calculator. You want to make sure that your left side equals the right side. That is the end of your practice test for Chapter 6.